Hello and welcome to the tool demo of GraphEvo, a tool that helps software stakeholders, including developers and testers, to understand the software evolution. GraphEvo provides three main features to help understanding the software system. First, it can construct and visualize the code graph of a given software system, whether it's written in Java or Python. It can be easily extended to other object-oriented programming languages. Second, GraphEvo supports each of the color graphs with a set of software metrics that can tell a lot of information about the graph, such as the number of nodes, the number of edges, the graph diameter, the clustering coefficients, and many other metrics. You can learn more about these metrics and their meanings at the tool's website. Third, and most importantly, GraphEvo can be used to visualize the graph evolution over time using color-coded graphs. These color-coded graphs can tell the developer or testers what changed in the code and where. This is the main interface of GraphEvo. It allows the user to either study one system at a time or study the evolution of a software system by selecting all of its releases and analyzing them. The user can simply open and select the files and then give a name to that project and hit Analyze. We see now that GraphEvo has analyzed all of the software releases and listed their graph metrics, including the release number itself, the number of nodes, the number of edges, the number of execution path within each call graph, the average degree for each graph, the clustering coefficient, and the diameter. These values are also visualized in an interactive charts to further enhance the visualization and exploration process. We see here, for example, that the JUnit version 4.3 has when some abnormal activities, the number of nodes has simply increased, the number of edges are also increased, and therefore the rest of the related matrices of that graph was also affected. We have actually manually investigated version 4.3 of JUnit and discovered that the increase in nodes and edges and other related matrices was due to an accidental error that included the tests and other sample codes in that version. We notice from this simple yet very important example that GraphEvo could greatly assist software stakeholders in different tasks. GraphEvo would be a great way to find this unintentional mistake if it was used by the JUnit team. Another important feature of GraphEvo is to visualize the network port rate divergence for each of the software releases in a color-coded matrix. A red color indicates a large change, while a yellow color and number 0 indicate that the versions are more similar. In addition to that, the user can click on View Call Graph for one software release in order to view the call graph of that software system. Software call graphs have been proven to help and assist software developers and testers explore the system architecture and its inner interactions. A very important feature of GraphEvo is that it allows the user to compare two versions at a time. The user can select the two versions and hit the Compare Versions. What we see here is a monolithic call graph that includes the call graphs of both versions that the user selected to compare. The nodes in green color indicates nodes that have been added in the new version and did not exist in the previous version. The nodes in gray color indicate nodes that have not been changed and that exist in both versions. The nodes in red color indicate nodes that existed in the previous release but do not exist in the current release. They are deleted. Thank you for watching.